Alright, so here's the next problem, and since you know what we're going after here, which is 1's on the diagonal and 0's everywhere else, then we're going to go ahead and start and write 5, negative 5, negative 5, 5, and we have 4, 5, 1, 4, and then 5, 4, 0, 0. Alright, now one thing that helps us greatly is if we realize this whole row up here is all 5s, you can divide both sides by 5 in this equation, in fact, or down here, and reduce that first row to just 1s, which is good because we like 1s, first off because they are a multiple of everything, and also because we want 1s, we want a 1 in the top left corner up here anyway. Alright, so I'm just going to divide by 5, and that's going to be my first step. And 5, 4, 0, 0. And my mistake right here, I need to change that to a 1. My mistake. Alright, so now let's take and we can multiply row 1 by negative 4 and add it to this row. So I'm going to do that now. Alright, so when I do that operation, I get 0, 9, 5, and 0, right? Negative 4 times 1 is negative 4 plus 4 is 0. That's what we wanted to occur. And then the rest of it just crumbles out from there. Negative 4 times negative 1 is 4. 4 plus 5 is 9. And negative 4 times negative 1 is 4. 4 plus 1 is 5. And then negative 4 times 1 is negative 4 plus 4 is 0 there. Now let's do that same thing again. I'm going to multiply the first row by negative 5 and add it to row 3. And that'll get a 0 there where that 5 is. So let's do that step. Alright, so now we have, in that row when we did that, negative 5 times 1 plus 5 is the 0 that we wanted, and then the rest of it works out to be 5 times 5, or sorry, negative 5 times negative 1 is 5 plus 4 is 9. Negative 5 times negative 1 is 5 plus 0 is 5, and then negative 5 times 1 is negative 5 plus 0 is negative 5. Now notice we can just take this row and subtract this row from it. Alright, let's see what happens when we do that. Alright, so we'll go ahead and do that now. So 0 minus 0 is going to be 0, and 9 minus 9 is going to be 0, and then 5 minus 5 is going to be 0, and then the last one is 0 minus negative 5 is going to be 5. Now this last row is going to be bogus. Think about what this means. If you have all zeros in any row, you got trouble because you have 0x. This means 0x plus 0y plus 0z equals 5. Right? Regardless of what x, y, and z may end up being, there's no way to multiply them all by 0 and have it equal 5. Everything on the left is saying it has to be 0, so you basically have a statement that says 0 equals 5. Alright, if you ever get all the things in a row to become zeros, and it works out like that, then you have the system is inconsistent is the answer, and you can stop right there because there's no need to continue solving this because you have an inconsistent system. That's what that means. So it's just like when you solved a system of two equations and two unknowns, and all the variables canceled, and you had some statement like 0 equals 7 or something like that. The same thing happens here. It's just in 3 dimensions now.